Hi guys, and welcome to project 2 of your flipped lesson series. Today we're going to be introducing a potentiometer and changing the rate at which your LED turns on and off. So to do this, we're going to need project 1 set up like this. So for this project I've made the pin output pin 2 instead of pin 8. We're also going to need a potentiometer, 3 more male-to-male development lines, and your female-to-female development lines. So you guys are probably new to the potentiometer, and I just want to run you through what the male terminals are at the bottom. So on the left we have the 5-volt terminal, on the right we have the ground, and in the middle we have the signal. The signal is what we are going to connect to our analog female terminal on the Arduino Uno. Alright, now to build your circuit and integrate your potentiometer, I've selected 3 development lines that are the same color as some of the female-to-female development lines here. So I've decided to choose yellow, green and blue, for which there is yellow, green and blue in here. So I'm going to go ahead and connect blue to the left handmost male terminal, which will be 5 volts, the green to the middle, which is our signal, which will become our analog input, and the yellow to the right handmost terminal, which will be the ground. Just done like that. So I'm then going to connect a male to the female connections, so yellow to yellow, green to green, and blue to blue. Now blue is the 5-volt connection, so we're going to connect that to the 5-volt input where it is labelled power on the Arduino. The green to analog 3, and the yellow, which is our ground, into one of the ground female inputs on the Arduino. So your circuit should look something like that. Alrighty guys, so now we're at the programming stage of getting our increasing and decreasing rate of a blinking LED. So we need to, like in project 1, we need to tell the Arduino what it is that we're going to be asking it to do. So we need to tell it which pins it's going to be activating in the program. So just like in project 1, go int, and working with our green LED, and we're working in pin 3. Now we have a potentiometer, we also need to state that. So you can call it whatever you want. I'm just going to call it potentiometer, and that also equals 3. Just like in the project 1, we're also going to say pin mode, we say that green is an output, and we don't need to state what our potentiometer is here, because if 3 is an output, well, green is the output, then potentiometer equals 3 must be an input. So void loop is where our coding for the potentiometer gets a little more complicated, in that we now need to reference the value which is coming out of the potentiometer and what we want the Arduino to interpret when it gets that information. So from the potentiometer, the minimum value is 0 and the maximum is 1023. However, when we get that information from the potentiometer, that's going to read out as a delay on our blinking LED as a number of milliseconds, and a 0 millisecond gap is going to be on, because there'll be no delay between on and off. So we're going to use a reference num, which I guess is short for number, and we go map, which is a code for changing the values which come out of the potentiometer. We're analog read, because the potentiometer is a analog output, and now we need to state the minimum value from the potentiometer and the maximum value from the potentiometer, and the minimum value that we want to come through to the Arduino, which I reckon is 100 milliseconds to 2000 milliseconds. And now whenever we want to delay the light from coming on and off, we can just stick the reference num in instead of having to put in numbers, which is how we can change the rate at which our light comes on and off. So the programming from now on is pretty much exactly the same as project 1, in that we go digital write, green high, we want to delay, and this is where we just put in num. So it's turning our LED off, and then we want to delay it once more. And here we have the completed code for the potentiometer changing the rate at which a light blinks on and off. To make sure it's going to work, as always, we go up and click verify, and it's going to work. Alright, so let's go ahead and join our two components with the coding and the circuitry with our communications cable into there, and this into